Alrighty, everybody. Greetings and welcome. My name is Robert Stone, and I'm here with
Shaun Ladewig.
All right, and we're going to talk to you about from OverTheWallOps to DevOps, how we have started using Openshift for our SysOps and engineering. And on that note, I'm going to turn it over to Shaun for a moment.
So really, as part of the overview of what it is we're going to go over, on the ops side, we're going to go over the infrastructure that we ended up setting up for this.
This is what's displaying. Okay. What's next?
Why it is that we decided to use OpenShift specifically for that infrastructure, the parts of OpenShift itself, if you were to do the same thing, how you would plan to set up a cluster, and then finally, of course, the maintenance for that cluster, and then finally, troubleshooting any common issues that you would run into with running that.
All right, and the recurring theme you're going to see that we have the combination of ops and dev. I think we're in the right place, DevOps. What I'll talk about in our OpenShift usage is first a high-level overview of how all of the different pieces are fitting together. We're okay? Cool. Then we'll talk about a step-by-step kind of discussion of components in depth, and then we'll talk a little bit about the real world and how we have gone ahead and migrated from what we have existing into the new hotness.
So, first question is, why OpenShift? Well, one of the reasons why we decided to use it was that you could get started fast. It's as simple as going on to GitHub, grabbing an Ansible playbook, making sure you have some boxes set up and ready to use, and then just filling out an inventory file. And the other reason was that it really is Kubernetes under the hood. So if we decided that we no longer wanted to do OpenShift, we could go ahead and use something that is basically a standard that everybody out there is moving towards. If we wanted to use the latest of any piece, we could easily replace any part. Also, it gives us, as a Perl shop, the chance to learn and love more YAML. So everyone loves adding more YAML, but getting the chance to do more stuff as infrastructure as a code, which is really one of the big reasons that Kubernetes kind of does the awesome stuff that it does, we were kind of excited about that. Finally, also it allows for, it's really, really easy to use. And one of the big things behind that is interfaces. It comes up with a really easy to use web console that even managers can sit there and understand exactly what it is that you're spinning up from the get-go without necessarily having to take the time to create a whole bunch of tooling. Also, it gives us the ability to do tagging, which really is more part of the Kubernetes stuff. But just being able to sit there and tag resources and just understanding that dealing with anything is just simple tags, which allows for you to do things as complex as you want to, or keep it as simple as possible. And then finally, everything is containers all the way down. So what we end up doing as ops is the exact same thing that our developers would end up doing with using the actual infrastructure. So whenever we go to do a deployment or release new versions of OpenShift or any part of the infrastructure, we follow the exact same path that all of our developers will. So we know that the tools are basically working in the exact same way. So now I'm going to start going over the parts of OpenShift. And really, a lot of these are just the parts of Kubernetes. So the first piece, of course, is the master nodes. And as part of that, of course, there is the Kubernetes classic stuff, the APIs, the scheduler, and then also etcd. And etcd really is the way that you get replication between everything. So that's where your objects or everything that's going to end up getting deployed lives. And it will be copied between all of the masters. Also, this is the layer that your web console ends up living at. The next piece is the infrastructure nodes. And really, you can think of this as just the central spot where all of your classic DMZ type stuff or just everything that's going to be a shared service. So really, the first big piece of that is this is where your router ends up going. So the way that traffic actually gets into your different apps or into your namespaces is really through this very first piece. And of course, there are also a number of things that OpenShift provides for us, which is a Docker registry, monitoring, lots of other great tools that just come out of the batch, and they just all end up on this infrastructure node. So, and then the other piece, of course, is compute nodes. And this really is where all of your apps go. And then one thing I will point out is that really the difference between an infrastructure node and a compute node is just simple tagging. So by default, an infra node really is everything that a compute node will be. You just sit there and say, this is where I want all of my shared services to live. So with that being said, I'm going to talk about planning for your first cluster. And really, this is going to be geared more towards people who aren't necessarily doing things in the cloud, and they're wanting to do stuff that is more of an on-prem solution. And a lot of the stuff I'm going to talk about really are specific to OpenShift 3.11, just because that's the latest. But one of the first things that I want to know as an ops person is, what OS is it that I need to be using for this? And really, one of the best things to use is just Project Atomic. One of the nice things about it is just it provides just the right amount of stuff that you need to actually spin up containers without any additional cruft. It comes as an image. You can just deploy the image and just use. The updates and all that stuff all work in a very simple, easy way that we've at least come to know and love with CentOS, but it's just basically something I can deploy over and over and over again and get consistency. Now, for the underlying hypervisor, really, that doesn't matter. As long as it can launch the Atomic stuff, it really doesn't matter what you use. We ended up using KVM on top of CentOS just because it's cake, but honestly, anything that you use that can launch the Atomic stuff really works out. But the reason why we did it in a hypervisor as opposed to installing it on bare metal, it's just so if we need to adjust what it is, what resources we have for whatever nodes, it's super simple for us to do stuff or migrate things as needed, or if we found out that we did something wrong, start over again. And then some of the important upfront considerations that you want to have, and the reason why I'm calling these out is specifically because you need to consider them carefully because you can't change these super easy later on. But the physical layout. So especially those who are very compliance-minded, you may find that you need to make sure that physical resources are only used for very specific things. So you just have to keep in mind that, hey, I want to make sure that these compute nodes will land in this physical space and potentially have things like my DMZ and stuff separated. Of course, this is all based on your needs, but just keep in mind that it is possible to do a lot of the compliance-driven stuff using OpenShift without an issue. Red Hat actually paid to have a sweet white paper done that basically goes into all the stuff that OpenShift provides for doing PCI workloads. That goes into more detail about what additional stuff you need to do on top of it, but almost everything that was written in it specifically just talked about just making sure if you put stuff in the right spot that honestly you're pretty good. The next piece is the network plugin. So there are 3 default ones that OpenShift provides. There's the OVS subnet, which basically means all of your containers can talk to each other. The second one is OVS multi-tenant, which basically means that each project is separated from one another and not able to talk to the other project, which was what we started off and made it super easy for developers basically to just spin up stuff without worrying that they're going to clobber on each other. And the final one, and it's basically the one almost everyone's going to end up growing into, is the network plugin or network policy plugin. So that will allow for you to express how things can talk to each other between namespaces. But of course, it ends up being a lot more complex because then you actually have to say, hey, by default, I only want to let these things talk to this or talk out to these. And a lot of developers we found just don't want to necessarily have to think about that off the bat. And then one of the things I'm going to call out, and I wrote it like this because it's specifically going to be an option from the Ansible inventory file that you end up putting in. But basically what this OSM cluster network cider means is this is the network range that all your containers are actually going to be spun up on. And this is important to know up front because this subnet is what gets divided into the number of nodes that you actually have. So if you pick too small of a subnet, you won't be able to spin up that many nodes. You won't be necessarily able to grow your cluster, or you'll have to find more network space that overlaps this. And so it tends to be painful. The next thing is storage. So obviously, since storage ends up having to talk to the underlying physical layer, you need to plan exactly where it is you're going to have certain pieces on your cluster so you can actually get to the pieces that you need. Obviously, this is important if you have different if you have different types of storage, like if you're using cluster, like a hyper-converged cluster storage stuff, you may actually have to make sure that the nodes themselves are being provided with enough space. That the nodes themselves are actually being provided with enough space so that you can actually do that. Or it may actually be as simple as you not having to worry about this because you end up using something like an S3 bucket or anything along that line. But the other thing is obviously the location of where that actual storage is, because if you have NVMEs because you want to do fancier stuff, or if you you want to end up using NFS stuff and it has to be in specific networks for use with whatever systems you're on, like you just have to keep in mind that you might not be able to move stuff as easy later on down the line. So we'll actually talk about physical layout. And I know this is not as exciting for a developer-centric crowd, but for the few folks that actually have to sit there and plan on how it is they're going to do it, if they're not actually doing any Kubernetes workload, we're going to start off with 8 physical pieces of hardware. And really, I'm just going to call out like how it is you can lay stuff out so that it becomes easier for you to do a lot of the compliance stuff. So the very first pieces that we're going to put in, of course, are masters. And I put them in this second one because we're really going to treat this more as our DMZ space. And it kind of fits that they're basically shared services between everything. And then the next thing is the infrastructure nodes. And so again, those go in the same DMZ space, because that's basically where all your shared services are going to be. But one thing I did call out is, so say if you actually wanted to do additional infrastructure specifically for like prod traffic or whatever, you could really move it out and onto a space where it sits in front of everything. So keeping that whole, this is the outer layer, and then you have your DMZ space. And of course, the most important thing the developers actually care about, the actual compute nodes, where all their stuff lives. And the nice thing about this is that if they end up using up too many resources, they kind of are boxed and not able to actually use up any of the resources from these or affect how the rest of the infrastructure stuff is going in. And of course, with that, if you need to, or if you find that you want to, you can actually separate out your prod into other physical stuff. But since all of this is all really just tagging, you can actually do fancy stuff where I say, hey, it doesn't matter. I can have this project live on both sides, or I can have it live across all of them. It's really just a simple way for you to divide up resources in a way that makes sense. But this will make a lot of the security guys happy because I can say, physically, any of the stuff that runs for my production apps never lives on the same hardware that the dev stuff does. And so if this gets rooted, it doesn't necessarily affect this or vice versa. And then a little bit of sprinkling of some additional network stuff. So one of the things that OpenShift lets you actually do is spin up a load balancer to actually bounce between all the masters in case stuff goes down. And this is just showing like a primary and secondary one. And then this OSNAP box is it could be anything from like an IP tables like firewall type system if you want to do that, or like an F5 appliance, or you can even just push it out to actual physical hardware appliances. So the next thing I'm going to go into as part of the cluster, obviously, that is important to ops folks is maintenance. How do I maintain it? And one of the very first things that we ran into was, how is it that I actually do cleanup or deal with stuff that ends up being messed up on this from devs actually using it all the time? The very first thing we actually ran into was the registry filling up. And because developers are able to sit there and actually make constant changes and use up and constantly try out different things, we found that the registry basically ended up filling up with tons of images that basically we weren't actually out and being deployed. So one of the nice things is OpenShift has a very simple command, OC prune images, where basically it will go look through for any images which aren't being used and let you clean those up. And it's very simple to put it on a cron or actually add it as one of your normal maintenance tasks for one of your admins to sit there and walk through. The other thing that we ran into specifically was developers being able to spin up projects. So one of the nice things is developers can get in, they can spin up a project, they can try something out, and then stop worrying about it. And it doesn't matter, that's still continuing to use resources. They just totally went ahead and did it. So one of the things that we found that we were really needing to do was come up with a system where we allowed the developers to use those same tags that I mentioned earlier and say, this actually needs to be long-lived, or hey, this is something that I'm trying out. And then we just go through and look for those. And since Kubernetes basically allows for you to do something as simple and non-destructive as saying, instead of actually deleting these resources, I will just spin them down. That's what we do. You can just do like go through each of the deployments and say, I want 0 available pods for all of these, so that they actually get the chance to sit there and notice that their app is offline if they want to, and actually can spin it back up and then go back through and retag it appropriately so it doesn't get reaped. And then if it stays too long in that status, we just go through and delete that project. And then the next thing I want to talk about is backups. So obviously with DevOps mentality, for the most part, backups shouldn't be too big a deal except for your actual data stores. If you can recreate every piece, you don't have to worry so much about that. Of course, that's idealizing everything, but there's a ton of Kubernetes specific backup systems that you could use out for the developers. But I'm going to focus more on the ops side of things, which the only really things that we found that we really have to focus on backing up are really etcd, on the off chance that we did have to get something that no one actually made a backup copy of or didn't sit there and deploy using like normal DevOps mentality, like using Ansible playbook or something like that, that we actually had a copy of the previous images. And then, of course, the configs on the nodes themselves, specifically for the rando stuff where, like, say, hey, we decided to change the authentication module or wherever like that, that we actually had a backup copy in case we had to go back to it. And then one of the great things about Openshift, honestly, is that it provides a lot of really great monitoring out of the box using Prometheus and Grafana. And there are a lot of great alerts that will occur if things are actually going wrong with the infrastructure. But one of the things that we got bit by pretty quick was that you have to make sure that these alerts are set somewhere you will watch, which is obviously the most important thing of monitoring. If you don't sit there and add in going to either that spot or having those alerts get generated and go to some place that someone's watching, they're kind of useless. But it's there and off the bat. And then finally, upgrading the nodes. So one of the nice things is that obviously, since this isn't a clustered setup, it becomes really, really easy to just evacuate a node, update everything on it as part of its OS, upgrade it, reboot, and move on through it. But actually, when it comes to upgrading OpenShift itself, since everything is containers, we're able to actually go through very simple playbooks and actually do upgrading the entire cluster. So in the case of actually using the Ansible playbook, you can just pull down the latest, go to the latest on that branch, and just run the playbook, and it will go through and roll through each node and upgrade it, starting with the control plane and working its way back. But one thing I will call out, especially if you're using like a hyper-converged storage thing, is that it does not necessarily account for GlusterFS and making sure that those stuff come back nicely. So you may have to read through that playbook and make some adjustments yourself. And obviously, one of the things that I have to deal with ops type stuff one of the next things I have to deal with ops is troubleshooting any issues or any common issues that come up constantly. And one of the very first things that when developers come to me, they're like, what happened? Why didn't this deploy? Why didn't this go out? And well, there's a very nice event page. In fact, it's at the very first place I end up looking for every single thing that goes wrong. And it ends up looking like this sweet little thing here. And it's actually called monitoring, and it is provisioned. There is a spot to get to it on every single project that is spun up in OpenShift. And it becomes very easy for any person to kind of self-service and figure out why things go wrong. Obviously, that doesn't account for the few times where it sits there and says, hey, I can't find a node to spin this up on. And then I'm like, oh, yeah, that's actually an ops issue. We'll find some place for it to go. And then as part of actually handling this, what we found that even for the ops side, if we treat everything as cattle and not pets, very much like what developers are used to, that it becomes so much easier for us to handle everything. And I have something showing. But for us, we found that if you use Atomic and the node is dead, then it doesn't matter because it's already been pulled from the cluster until I reload it. And then instead of actually trying to fix the node, I just delete the node, reload, scale back up, and add it back into the cluster. No harm, no foul. And as long as I didn't delete any of the actual data stores in any of the volumes that were attached to it, then everything just goes back to as it was. Just like everyone ends up doing with all their actual apps. But the nice thing is being able to do that even down to the node level really helps out. And so now I'm going to turn over to Robert Stone to do a high-level overview.
All right. Well done, sir. Okay, so at this point, we're going to go into the high-level overview. This is also the point at which videographers tend to hate me because I do this. So sorry, you don't have to follow me, I promise, it's okay. So what we're going to talk about here is we've just heard about how the infrastructure itself works. Well, now it's time to talk about how we actually consume, as engineers, that infrastructure. We're going to start with a very high-level overview, then we'll dig in and we'll talk about what the different pieces are. First off, we have this concept of the upstream Docker image. The Docker image is going to be used inside of our first build config. This build config is going to ultimately produce an image, which will be part of an image stream. From here, we actually go into a second build config, and we'll talk about the difference between a Docker and a source build config in a moment here. This will result in our second image stream, which is now going to put us into a state where we have to start thinking about our secrets, our volumes, configs, things like that, so that we're able to actually create the deployment config. Now, the deployment config is our actual running pod, and pods are going to be composed of containers. Don't worry, we're going to go through all of these, I promise. Once we have something that's actually running, it becomes important to have a networking component associated with that. And this is where we will discuss service, route, and of course, the obligatory cloud image, because it doesn't count if there's no cloud in the presentation. So let's get started very first. Did I walk way too far? No, I'm good. We'll start first with the upstream Docker image. Now, I'm going to act under the assumption that most of us are familiar with Docker. Great. Okay. But when it comes to what we're using it for all intents and purposes, it is just the underlying operating system. Now, it need not be. You know, you can get some really fancy Docker images, but for our purposes, we're going to focus on it's just the operating system. We have talked a couple of times about how we base it on an upstream image. Probably the first question is why? Why do I base it on an upstream image? And the reason we want to do this is I'm really, let's pretend great. People I work with here, so they'll probably lie. But I'm really great at software development. Not so great with underlying the server itself. And I don't want to have to worry about security fixes, patches to the operating system, and things like that. By using an upstream image, I'm able to benefit from everything the community is producing so that I can focus on my actual app. Okay, we talked about the Docker image. Let's go into our first build config. This is the actual, okay, we're doing good. This is going to be the Docker build config. Now, build configs are little more than recipes for making an image. And we focus on the fact that this is a Docker build for one simple reason, the concept of got root. This is going to be the place where I perform operations as though I was root. This is where I'm going to be able to install RPMs, install other server applications, Apache, MySQL, Redis, Jenkins, so on and so forth. This is also going to be where I set up the S2I scripts, where I basically put the source to image scripts inside of my build so that I can consume them later. Okay, so we've gone through here, and now we're talking about the first image stream. Well, let's talk out first what an image stream is. For lack of a better term, it really is just Git for completed builds. It's a collection of builds, hence the name image stream. They are tagged. The most common tag you'll probably see is latest. Okay, pretty straightforward, latest. But it doesn't have to be latest. You could call it whatever you want. You can use version numbers, you can use dates, anything like that. The other advantage is that it is watchable. And the reason watchable is significant is because I can use changes in the image stream to drive and trigger downstream events. Cool, all right. I'm not sure how that's going to come in handy yet, but for right now, we'll keep that in mind. Now that we've talked about this build config, which was the source build config. Oh no, now we're going to talk about this source build config. Okay, so the source build config is a source build. And I have a very advanced graphic right here to show you guys what I'm talking about. It's not that advanced. We have my source code, which is in Git. This is going to be the assemble step of S2I. So once we finish our assemble step, we're going to be ultimately left with a completed artifact. Now, everybody handles their artifacts differently. For our purposes, I want to keep a couple of pieces in mind for this source build step. The first is that I'm incorporating my actual source code. Everything that I've done previous to this was really just to focus on the server that's going to serve my stuff. It does run as an unprivileged user. Again, we're keeping that separation between what happens in the Docker build versus the source build. And the primary goal here is to put stuff in the right place so that I can produce a runnable image. That's the real output of my source build step, a runnable image. Okay, now that we've gone through that, we'll talk about our second image stream. This image stream is actually a collection of deployable images. And this is where I'm going to talk a little bit about how Endurance is managing using tags. We're using 3 different tags. We have the concept of development. This is going to be a build that is deployed in the development environment using development secrets. Next up, we have the concept of staging. Staging will use production secrets, but is not customer accessible. Lastly, we have production, which is going to use production secrets and is customer accessible. And I can move these tags back and forth throughout my image stream as needed to control not only to control what's in production, but to also be aware of what's in production. Okay. We're going to treat most of this deployment config and secrets as one piece. We're going to talk about those now. Well, the deployment config is really going to be the primary focus of most engineers. That's where I'm going to do most of my work. That's the thing that runs, the thing that looks pretty. Deployment configs, we'll start off with the concept of a container. Now, containers are, when they start up, that's where S2I run occurs, which is basically how do I make my app do the thing? How do I make it daemonize? How do I get it served? Anything like that. And you don't necessarily have to have only one container. You can have multiple containers inside of a running pod. And what we will focus on for that is the additional pieces that are composed into the container to make everything work. First off, we have the concept of mounts. Secrets is probably one of the primary things that get mounted into containers. But they need not be the only thing. We have the details of configuration. We have any persistent volumes that I want to use for storage, or the fact that it's a non-persistent volume. We also want to focus on the environment. Depending on what source code you're using, like if you're a Node.js shop, you're probably pretty used to using environment for pretty much everything. Depending on your source, you will either use environment or more of a file structure-based collection. The containers themselves, as a group, comprise the running pod. And the pod is the actual running application, the thing that's of the most interest to me as an engineer. Now, there are a couple of other pieces that can go into the deployment config, the first of which is going to be resource allocation. This is where I can limit the amount of CPU and memory that are allocated to my running app. We also have the concept of health checks. And there are 2 health checks that are of particular interest. We have the concept of the liveness probe. We also have the concept of a readiness probe. Anytime a liveness probe fails, Kubernetes is actually going to reap the entire pod and spin it back up. Again, cattle not pets. Thing dies, no big deal, spin it up again. Well, don't you want to debug it? No, I don't really care. Just spin up a new one so that I can actually provide service to customers. The next is the readiness probe. And the readiness probe is used most oftenly when you have multiple running pods inside of like a replica set because you need multiple pods to serve your need. If a pod fails a readiness check, it won't be killed, but it won't get any new traffic. This is also a consideration when you're first spinning up. The other details of a deployment config that are significant is first the fact that it is triggerable. Now, we talked a little earlier about how image streams can trigger downstream events. We have set up our deployment configs to automatically roll out the latest versions based on changes in image stream. And that is also a detail of how deployment configs can be versioned. This allows us to roll out to go to the next version or roll back in case there was an issue. That is the deployment config. Great. What I want to talk about now are the actual networking concerns. And the networking concerns break down into two kind of core aspects of OpenShift. The first is going to be the concept of a service. And a service is used for internal routing. It is the internal load balancer, and it is a proxy to the running pods. Well, this is all fine and dandy as long as I'm able to communicate inside of the cluster, but that's only going to get me halfway there. In addition to services, we need routes. And routes are what establish external connectivity. This is what expose a service. An important consideration is that it is via hostname, which works out great for most sources. And I'm going to wrap up in just a second here. This works great for most sources, like Apache, things that have a hostname. But protocols that don't have an underlying support or concept for a domain name struggle with route usage. For instance, if you're trying to connect to a MySQL database that's inside of the cluster, you're going to have to use something like port forwarding in order to make that happen. In addition to the actual exposing of a service, routes can handle TLS termination. In a lot of our projects, we have already baked in the SSL certs. This is also an excellent opportunity to use something like OpenShift Acme to get Let's Encrypt to provision your certs for you. Okay, so what we have talked about is this entire high-level kind of discussion on how the different pieces work. We're pretty short on time, so I'm just going to very briefly speak about one or two aspects. We are keeping this dividing line, our Docker images, are existing inside of a single shared project that all of our engineers are consuming. This is where our actual builds are occurring, and this is going to be for our source code, the things that we're changing. I'm going to turn it over to Shaun for a moment. Shaun, would you talk about how we're using the additional container for configuration?
So yeah, one of the things that we were trying to do, and I'm going to try to go real fast with this, is when we're actually spinning stuff up VMs, we'd have Puppet configure a whole bunch of secrets for us because we consume stuff in a very specific format. And so what we decided to do is basically add it as a sidecar image, and we would go ahead and spin up and run our Puppet, grabbing secrets from the mounts, writing them out in the correct way, and then providing that as a read-only mount to the actual app itself. So kind of helping us to bridge the gap very quickly between what it is we're doing for VMs and actually getting stuff in containers. So basically, we could consume all the stuff we did in as a VM, as running as root, and shove it into a container so we could actually start working towards DevOps.
Fantastic. All right. Well, we would love to talk more, but unfortunately, we'll have to run. But thank you all very much. It has been a real pleasure. Great job, Shaun.